So the idea with this session today is just to provide some reminder on the EUDR requirements of on zero deforestation and the implications when it comes to due diligence. Looking at some of the sources of data, but really the focus of today's presentation will be to look at the role that national data, national forest cover or national land use or land cover data can play in due diligence. And to do so, we will take the example of national data existing in Côte d'Ivoire to take you through a little bit what could be a potential approach to using the national data and how it can be used in combination with other data sources to feed into risk analysis in the context of the EUDR. And then we'll obviously, after this presentation, be very happy to answer questions, but also get your comments and your suggestions and your basically experience as to the use of national data and others so far. I don't need to go in the antitrust statement anymore, but just a quick disclaimer to be very humble and also explain that as EFI, we work with all stakeholders to try to build solutions, especially open source and sort of public solutions that can help all stakeholders in the supply chain meet the EUDR requirements. And we do our best to understand what is required and the implications for all the different parties, but we might also make mistakes and we don't have all the answers to all the questions. So this is very much the sort of the result of our experiences so far in country and working with different stakeholders that are on the same boat, let's say. So to start with, just a quick reminder on the EUDR requirements and the implications. I'm not going to go into the details there. You know that the EUDR requires three main type of requirements around traceability, around the legality of the products, but also around the zero deforestation characteristics of the product. And that's where we are going to focus today. Operators that are putting cocoa or derived product of cocoa on the EU market will have to demonstrate that this cocoa has not been produced in an area converted from forest to cocoa or to agricultural use after 2020, so not deforested after 2020. And to do so, there is some evidence that needs to be collected and kept by operators, and some specific data sources that might feed into the analysis and this sort of evidence building in the context of the EUDR. And since the EUDR is using this cutoff date of December 2020, of course, the state of forest in 2020 is one of the primary data sets that is quite important to use, but it's not necessarily the only one. And we're going to look into that into a bit more details. The EUDR uses a number of definitions that are international definitions, including coming from the FAO. That's the definition of forest of FAO in particular, that might not be the same that is used at the national level by the different origin countries. And it also offers a definition of deforestation, of agricultural use, etc., which have a number of considerations that or implications that we will see ahead as well. It's important also to note that this zero deforestation criteria comes on top or in addition to other criterias. And all in all, these three criteria that you've seen at the beginning, traceability, legality, deforestation free, they all need to be cumulated to be able to ensure compliance. And in particular, something that might sometimes be misunderstood or sensitive in some origin countries is that the zero deforestation criteria applies even if legally in the country it's allowed to convert a forest after 2020 to plant cocoa, for instance. But the EUDR sets this limitation as part of its overall objective to reduce the impact of agriculture and EU consumptions of key agricultural products into global forests. So this evidence, but you already know that, needs to be also kept for quite some time. And I think what's particularly relevant for us today is to look a little bit more into the details of the FAO definition of forest, which operators need to consider when doing their due diligence. And what's important to note about this FAO definition is that it combines two approaches, in a sense, two type of criteria. On the one hand, a biophysical criteria, so some biophysical characteristics that a group of trees need to reach to be able to be considered as a forest, and that's a minimum area of 0.5 hectare. With trees that are more than 5 meter high or are able to reach that height, and a forest cover, a canopy of more than 10%. 10% is not a lot, and we'll see that in many countries actually where cocoa is produced, national definitions usually consider a canopy cover that is actually greater than 10%. So that might be sometimes a source of difference between international and national definitions. But it also combines a land use criteria. And this is actually excluding agricultural plantations and the land which is primarily used for agricultural or urban purposes. So even if this biophysical criteria is met, if the purpose of the use of the land is not that of a forest, if it's that of an agricultural area, so if the main purpose is to grow crops, or if it's of an urban purpose, then this area would not be considered a forest, and that's quite an important element for the EUDR. So it means then that agricultural use can refer to cases of land that are under either permanent crop or long-term crop, such as cocoa, but also multi-year temporary crops, such as food crops. And the EUDR also talks about the situation in which agricultural land is set aside. So it also covers set aside agricultural use, which can be more or less understood as concerning when the lands are in fallow. So basically when there was agricultural use, but the land is being left to regenerate or to rest, and at a certain stage might reach the definition of forest again, because nature has just taken over again because of that past agricultural use, and that's in principle sequencing of type of land use over time. This area of land would still be considered under agricultural use. There are obviously implications as to how this definition, or sort of the details of the definition, and the regulation is not really providing a lot of details, especially when it comes to understanding sort of for how long we can consider that the land is still considered under agricultural use after a certain date. The FAO, for instance, uses a maximum duration of 5 years. So if after 5 years a plot of land is still under fallow, it's considered as abandoned, and then gets back into the forest category, if you like, if the biophysical considerations are also met. Another element of the definition is that agricultural use also needs to be predominant. So again, how to define that? So it's clear from the regulation and clearly stated that, for example, crops in an agroforestry system, even if the overall land meets the biophysical requirements of the definition of forest, it's still an agricultural land, because an agroforestry system is predominantly an agricultural system. It's meant to grow food and crops. So what could be actually the cases of productive land that don't have a predominant agricultural use? It's not so clear, but maybe we can think of the cases of wild cocoa or coffee, for example, in the Amazon regions in Latin America. But yeah, well, it's still, well, for the moment, a bit of a question mark. The European Commission also is still working on, as you probably know, some guidelines that will include aspects related to agricultural use. So hopefully we will also know know some more details. But with these examples, I think we can already see that the predominance of the land use criteria can also really have implications when it comes to collecting and analyzing information for due diligence purposes, because just with satellite imagery, you might not necessarily be able to get all the information necessary to evidence that use. So a few examples, just to put these things into practice, on what could happen on a plot. So these very basic squares represent a certain plot of land. And so the first scenario is a simple one. When conversion of forest to cocoa or another crop happens after December 2020, then this crop is not considered as compliant under the EUDR. If conversion on the plot happens before or after 2020, but it's not for an agricultural use, so for instance, it's a urban use, so the farmer builds an extension to his house, for instance, on the plot, then this doesn't have any implication in terms of compliance, because the definition of deforestation of the EUDR only considered deforestation when it's a conversion to agricultural use. So other uses are not considered deforestation. But yet, if that conversion happening after 2020 is for an agricultural purpose, although it is not necessarily for cocoa in that context, so that's the third case, then the cocoa from that plot would still be not compliant, because there has been deforestation driven by agriculture taking place on the plot. There's a little bit of unclarity still about whether we consider any, or the EUDR would consider deforestation from any type of crop, including food crops, or just EUDR relevant crops. But let's say that from a conservative point of view, if there is any forest disturbance on the plot that is driven by agriculture, it's a big warning sign in terms of compliance. Other examples. So if conversion of another agricultural area is happening to cocoa after 2020, the cocoa is still compliant. For example, if there's banana on a plot in 2020 and it's converted to cocoa after, there's no problem, because it's conversion from an agricultural land to another agricultural land. So there's no change in the forest cover in principle on the plot. But cocoa coming from any land that is deforested after 2020, so that's the third cases on this slide, would mean that it's not compliant. So if you have after 2020 conversion of forest to banana, and then in 2030 this banana area is converted to cocoa, well, then the cocoa wouldn't be compliant, because ultimately the forest has been converted after the cutoff date. And the middle scenario is this fallow land scenario that I mentioned before. So if there was agricultural use before 2020, left in fallow or abandoned, leading to forest regrow, and then there's conversion to cocoa afterwards, the compliance of this cocoa might, of course, be questioned, because certainly the satellite imageries will show that it was forest in 2020. So there, the operator would need to demonstrate previous agricultural land use, for sure. So now moving to what are the type of data sources that can be used to demonstrate compliance. First, a word about the fact that I think, as was just illustrated, satellite imagery and remote sensing can play a very big role in all this, but it also has its limitations. So forest cover aligned with the FAO definition and for the year 2020 is obviously a key source of information. There's a lot of information of data out there from public sources, but also commercial global data sets, different levels of accuracy, and also different levels of alignment with these definitions. And where we want to concentrate today is on the role that potential national information can play, if it's available and if it's of good quality and if it's also aligned with everything that was just explained. But from our experience working with a number of origin countries, we actually see that the use of national data can have some potential very interesting impact or use for EUDR due diligence. Before moving to the national sources, just also to mention that at the global level, as you probably know, there's a data set that was just launched a few months back by the EU Joint Research Center, which is the global forest cover map, which is a resource that is available at the global level. So its accuracy is also limited, but it's publicly available and it's meant to serve let's say, as a potential source by default when there's nothing necessarily more accurate that exists, or as a potential layer that can be used to cross-check information as well, as we're going to see a bit later in the presentation. I want to spend a bit more time to tell you about what is happening or what is available in some of the countries that we're working and some of the main cocoa producing countries as well. So as I mentioned, I think it's quite interesting to look at what's available because national level data often provides greater accuracy. They're usually based on field data, on national circumstances, etc. So also provide sometimes more granularity and local verification. And there are some countries basically which have some data products that are directly aligned and or even that might have directly been produced to support due diligence for the EUDR. There's a few only at this stage. Maybe more countries are now getting interested in developing or adapting some of their data to support their supply chains, but I think we will talk about Côte d'Ivoire, which is a bit of a case study here, but also to mention that Cameroon is in the process of finalizing a forest non-forest mask that will be publicly available this year, as well also as a cocoa layer, a cocoa probability map that will sort of be available as well in complement this year. And then you have many other countries which have existing data sets for 2020. Some have data sets, but not for 2020. So that's a bit more maybe difficult to take advantage of. But many countries actually have data sets for 2020, but which might sometimes need some tweaking because there are some differences, in particular with the definition of FAO and the minimal mapping unit that is being used. In particular, you can see that several Latin American countries have well-developed forest monitoring systems that generate actually annual data, so including for 2020, not only on the forest cover, but also often on land cover, also on land use change, deforestation, fires, hotspots of deforestation alerts, etc., etc. So there's quite a lot of things available online actually, and for free, and mostly in most cases that can be downloaded. But again, the limitation sometimes is that the forest definition is being used, and it's often not the same as FAO. Usually, there are some differences in terms of the canopy cover, and sometimes also in the minimal mapping unit, which might be higher. Of 1 hectare, so there might be some granularity lost from this data. So I will stop here and pass the floor to my colleague Carlos, who will now give you a bit more detail about what Côte d'Ivoire has developed in terms of data, and also more importantly how that can be used for EUDR due diligence. So over to you, Carlos.
All right. Can you hear me clearly?
Yes.
Yeah, all right. Yeah, so thank you, Darlene. Yeah, my name is Carlos Riaño. I'm based in Malaysia. Well, I'm here today. I'm here in Vietnam. Well, the next part is the Ivory Coast map, so Côte d'Ivoire map of 2020 land cover. This map was produced by the government, so the Ivory Coast government, through the national institutions. It's called Benet CIGN, is the National Geographical Institute. It was supported financially and technically supported by the European Union. So what you see here is the result, is the map that was finally produced by the government. It respects the national definition of Ivory Coast, but also, and we will see it in a moment, it can be adapted and adopted by the FAO definition, and some sort of specific technical specification. Something interesting is the 10 meters spatial resolutions, and also the overall accuracy that is above the 90%, right? Also to highlight that there was an external validation carried out by the Joint Research Center of the European Union. So very briefly, this was the methodology. On one hand, there was the field data collected by 5 different teams, and then there was a mosaic taking the Sentinel data for 2020. All the data they were all pushed into Google Earth engine to create an algorithm. And at that stage, they input other data that we will see in more detail. And then there was the validation, the external validation, using very high resolution imagery by the GRC, as I mentioned before. There was a process of revision, a little bit of edition, and getting the final map. This is the technical part. Next one, Adeline. Right. So something that is important here is the commitment of Ivory Coast by presenting. I think this is one of the first times when Ivory Coast, Côte d'Ivoire, they make it available, this map, to download it, right? So it's an open source platform. Well, it's an open platform, not open source, but open, that can be downloaded. And we are working with the government to make it available also through the Google Earth engine. All this data is accessible, not only the data, but you will see when you go to the website that also you can download the metadata, you can download the methodology, so all the explanation that is there, including some land cover maps with the cultivated land, with the forest land, with the coffee, cocoa areas, and so on. So quite useful, not only to check, but also to download and make your own analysis. Next one, please. Okay, so we have that map, and here the point is how to create the forest mask, how to make this map useful. This is mainly the question when we are talking about zero deforestation or the risk assessment in the framework of the EUDR. So how we use it? This is, let's present it here. So four practical or pragmatic steps. The first one is to know the land use classes, is to know the map that we are using. This is the case here today, I say Ivory Coast, but it can be also Ghana, that can be Cameroon, Ecuador, etc. So when we know the land uses classes that are usually there in the descriptions, in the methodology, we need to prepare a forest no forest map. We need to be conscious and review the minimum mapping unit, see if it's adapted to the FAO definition, and we need to work with the map, we improve the map, make some filters, and absolutely use additional information. So in the case of Ivory Coast, we have different classes, and each of these classes, they have a definition. There is one class that pull our attention and is the wooded savanna. So when we go to the definition of wooded savanna, they say that it's a strata of trees between 5 and 20 meters high, covered by a 10%, is not an agricultural use. So what we have here with the wooded savanna is a class that respond to the FAO definition. Under the national definition, this is not forest. Under the FAO definition, is considered forest. In fact, when we see the comparisons, we can revise and check, and we talk with the government authorities, and they say, yes, it can be done, right? So how we do it? So first we have the first image on the left is the map, the land use map with all the classes. Then we converted one into the forest, no forest, so is the image at the center. And we can filter out the wooded savanna and reclassify it. This is something that a GIS expert or remote sensing expert can do very quickly, something 10 minutes, and reclassify that into forest. So we have a forest, no forest mask, that is the one on the right, that respond to the FAO definition, that meet the requirements. But this is not enough, because now we are combining some classes together. And when this happens, as a result, we could have some areas that are lower than my FAO definition of forest, right? Remember, so in the case of Côte d'Ivoire, Ivory Coast, the minimum mapping unit is 0.1, and in the FAO is 0.5. So this area here, the area is bigger. So we can have some small island of forest under the national definition that are not needed under the FAO. Okay, so what we do here is to using a series of tools, of filters, they will count the number of pixels that correspond to from 0.001 to 0.5 hectares, and we exclude them. When we exclude this island or this piece of forest of wood, we will obtain our final layout, that is the green areas. In this image, you can see that there are like two sort of forest. One that are in the natural boundaries, so the one that can be mixed with the agricultural land uses, and you will see the big portion is part of a protected area. So this is a good example where the definition works independently of the legal status. Okay. So here, yes. So here we have that part. So at the end, the red area is excluded. So what else do we need to do? We need some additional parts, because until now we are just been using our data within the national data, but this is not enough. And this is a clear message that we want to pass to you. There is no single data set, no single map to determine the conformity of the commodities with the EUDR. It doesn't exist. Until now, all maps that any country had was not designed, was not developed to comply with the EUDR. So operators, they must be mindful, and the idea is to combine all the information that exists. Okay, we will see in the next slide some of the examples in this case. So here we have additional data that can be used. We already referred to the JRC forest cover map, the 2020. This is available. The Japanese corporation, JAXA, they also have a forest cover map. Then we have something that is quite common use is the one on the left down is GLAD. This is from the University of Maryland, the tree canopy cover. And here we need to be careful because we are talking about tree canopy cover. We are not talking about forest by itself, but we can transform it. And there are some land cover maps at the global level. One is from Copernicus, and the other one is from the European Satellite Agency, ESA. They have both land cover maps, and here we specify this cover, and you can see, for instance, the ESA map, it's mainly green for Ivory Coast because we are talking about land cover. And some extra information in the case of some countries where protected areas, the national protected areas boundaries are not funded. There is a website, the Global Dataset of Protected Areas, WDPA, that can be useful. It can be useful, I say, because there are some issues there with the data, depending the country, but useful anyway if there is no more option. Finally, in the case of Ivory Coast, there are other information that can be added. For instance, recently WRI for Ivory Coast and Ghana, they developed the risk of deforestation map in the coffee belt. ETH Zurich, they have a map of the probability of cocoa that can be there. And for any other information that can give you topography, additional points, some mapping in general, that it exists OpenStreetMaps. So it's something that can give you a general idea. OpenStreetMap data, this is not raster, this is vector, so we are talking about lines, polygons, and so on. But that all the data can be downloaded, it can be used. They have a good source of roads, paths, etc., where we can have an understanding of the environment we don't be in the country. Okay, so we have all that. We have our national map and we have all the additional data. What do we do with that one? How we combine it? How we make the analysis? So this is an example that we have that we made with GRC together. So we overlapped in this example the national data with the GRC forest map, and we can go to some conclusions, saying that, well, as expected, the national map, they provide us with more accurate data than the GRC one. That we can already confirm some areas where both maps or more maps, they all agree where the forest is. Okay, and working with that, we can say, okay, if I have a preference for the national map over the global data sets, I can work on some combinations, right, to get my final probability map. So how we do this? We can do it on the decision tree. So this is an example, quite useful example, when we develop a tree based on 2 or more datasets. So the first part, we get the combinations, and we have the first questions. There is a presence of forest? No. Okay. So we have a low risk or negligible risk. We go there. If yes, do we have the presence of forest in only one of the maps? Or if we modify this decision tree, we can say, is this my national map? Say yes. Well, okay, we trust it. Or in this case, okay, we just use equal probability. So one map, we can say, okay, this is medium risk. There is no presence of forest in my national, but my second one, that is the global one, say that there is no. So we have 2 maps that say that there is no forest. Then we can think that is high risk. And until now, we have used only and exclusively land cover or land use of satellite information or geographic information, right? We go to additional checks, and those additional checks can include different products. One of them, and it's something that we can check, is the very high resolution information. In this case, we are presenting the two examples where we cross-check the two maps, and we say, okay, in the example on the left, we have the forest. That is forest according to the JRC map, but what we have in reality is so our validation points. They say, no, look, this is in fact, this is rubber, right? This is a rubber plantation. This is not forest. Okay, right? So this is a false forest classification on the GRC map. Now, on the other hand, we have the same part. We have our verification plots, and we have that is in this case these are forests in our system, right? So we can have those very high resolution data to demonstrate some of the inaccuracies in our maps. How we do this? Which other data can we use? We need to focus at the plot level. So when you have your decision tree, you can clean most of your data, but there will be some of your plots that they will need this additional information. And our recommendation is to not stand only with the geographical information, with the geo information, with satellite images, with maps and so on. We need to go further. Field verifications, land use chain data. Like if you do the time series and during the time series in this analysis, we know that there are changes. Okay, that detecting that the plot is changing. No geographic information like land certificates, cadastral data, something that demonstrate the agricultural use before 2020. Okay. The other one is deforestation alerts. And finally, and this is important, when you clean all that and you still have some questions, the commercial data analysis is important. This is where it comes. So you can combine open source available data with the commercial data. When you still have some plots with issues, this is where we say, okay, let's use and let's top up with this commercial data analysis that can help me to clarify. Not my whole set, but those set that we think that they have issues and we need to go further. Okay, so this is all for today. Our contacts are there, and we are happy here to continue the discussion. Thank you very much.